The airplane I'm building is called a Falco. It's designed from Italy, 1955. And even though it is 60 plus years old, it is considered by many to be one of the most spectacular airplanes around in terms of its appearance, its style, and in terms of handling. It is considered by pilots way better than me to be one of the finest handling airplanes around, even in 2019. One of the most enjoyable parts of the whole building process and getting involved in aviation in general is the number of people, both locally and internationally, who have an interest in aviation, and particularly the Falco aircraft. I have a building partner, Bob Trumley, and if his interest level is low and mine is high, I motivate him and vice versa. So it works out very well together. What I'm looking at Javelin Technologies to help us with in this particular instance is the construction of the wheel well doors. Each airplane being hand-built differs very slightly from the drawings, no matter how much you try to be as accurate as possible in the construction process. But there are little changes here and there. In order to get a perfect fit of those wheel well doors, we thought that doing it by 3D printing would be the answer. Because of the location of the doors underneath the wing of the airplane, not only is it difficult to get to, especially if you're doing trial and error, but the curves, the complexity of the shape is such that doing it manually is going to be somewhat problematic and time-consuming. 3D scanning is going to solve all of that problem. If we built the doors the conventional way out of a fiberglass layup, it will be a heavier door. And with airplanes, it's always important to manage the weight. So every ounce we can save here and there is important, but also of a material that is aviation approved. So we'll end up with strong doors, lightweight doors, and accurate doors.
What we're actually doing here is we're capturing information that we can then reverse engineer in order to create the landing gear components that are needed for printing. Reverse engineering is necessary in instances where we don't have access to either part drawings or accurate part drawings that are true to the actual form, or we don't have CAD information. How reverse engineering with scan data works is, first, of course, you have to capture the scan information. Once that information is captured within Artec Studio, we export the information directly to SolidWorks using the Geomagics for SolidWorks plugin. We chose the Artec EVA because of its field of view and the level of accuracy that it offers. So for this project, our tolerance is actually 1/8 of an inch. So with the tolerance of 100 microns, the EVA was a great fit for that level of accuracy. Because we are under the aircraft and it's a rather large area, it's very important to utilize a scanner with a large field of view. The Artec EVA has about a 1 meter field of view, which allows you to capture a lot of information very quickly. With that field of view tied in with the 16 frames per second capture rate, we're able to capture the information very quickly and easily. We're saving Michael a lot of time by scanning this information and reverse engineering it rather than having him manually measure and create multiple instances by hand of this component. You get the information right the first time because it's right there for you.